Hi everyone, welcome to this video about the Extreme Propeller Launcher. This is an evolution on the Supreme Propeller Launcher and it performs a lot better as you can see. This new version of the Propeller Launcher has been designed from feedback that you guys dropped on the first video, so your comments were actually very useful in developing this new version of the Prop Launcher, and also my own testing results. So the first change has to do with the Propeller Connector. The old design relied on a trigger system and the new one relies on a helical corkscrew system. So the old design was a lot more complex, requiring multiple parts to hold the propeller in place, including a bearing mounted on the propeller, increasing its mass. The new design requires no parts whatsoever except the connector itself and is a lot more simple. The second major change has to do with the addition of variable blade pitch on the propellers. This is the old propeller with a fixed pitch, and this is the new propeller with variable blade pitch. This does optimize the lift generation by quite a lot, and the reason why is actually quite fascinating. Let's see why. Let's consider a propeller flying. It has two velocity components. First, its rotational speed in revolutions per second, and second, its forward speed. The propeller has a radius r, and the speed of any point along the blade due to the rotation of the propeller can be calculated by multiplying the circumference it traces by the amount of revolutions per second. Then, if we look at a section of one of the propeller blades, we can draw the velocity vectors we discussed. First, the blade velocity from the rotation, and second, the forward propeller speed, which is constant for any portion of the propeller. Together, these two velocity components trace a velocity triangle, of which the hypotenuse represents the direction of the relative wind. The angle between the wind speed and the plane of the propeller is the wind speed angle. Then we must add an angle of attack on top of it for the airfoil section to produce more lift in those conditions. In my design, I selected the angle of attack which maximizes lift, so about 12.5 degrees, for my airfoil section. Finally, the pitch angle of the airfoil section is calculated by the sum of the wind speed angle and the angle of attack. For the updated propeller design, I calculated the pitch angle of the airfoil from the core of the propeller, which has a radius of about 9 mm, all the way to the blade tip at around 55 mm. You can see that the pitch angle varies quite significantly throughout. Near the core of the propeller, the ideal angle is 57 degrees, and at the blade tip is about 22 degrees. This is because the velocity triangles change quite significantly due to the difference in blade section velocities from the rotation of the propeller. Near the core, the velocity of the blade section is quite low, and therefore the angle is quite steep in terms of the wind speed. And towards the blade tip, the velocity of the section is quite high, and therefore the angle of the wind speed is quite shallow. So this change will drastically improve the amount of lift generated by the propeller and should result in a large increase in its range. The next change has to do with the gearbox design. You can see on the left the old gearbox and the new gearbox on the right. You may already see the big difference. So the old gearbox had a flaw, basically where the small spur gear that you see in white here actually sees the highest amount of stress of the whole gearbox because of its size and also because it's on the first set of gears of the gearbox. And this was causing issues. Basically, this gear was going to split with any high amount of torque input you would put on the handle of the propeller launcher. You can see how it failed, and that really limited the amount of energy you could store in the propeller and also your fun, because let's face it, if you're trying to throw a propeller and this gear breaks on you, it ruins the whole fun, right? So I actually increased the face width on the new gear design by about 50%, which also increases the strength of the gear by 50%. But I've also changed the gear design to herringbone gear, and that type of gear actually has a lot higher of a load bearing capacity because the load from the other gear is being shared through two or three teeth at a time instead of just one on the previous design of gear. So All in all, my testing with the new gearbox, I haven't yet been able to break the gearbox. You'll see in the testing videos I'm torquing this thing as hard as I can, and it still takes it. So I'm really happy with this new gearbox design. It's much more reliable. A last update I've made to the design is the addition of a ground effect plate, which should increase the lift produced by the propeller just before it launches. So, ground effect is a phenomenon where airfoils produce more lift when flying close to a ground surface. So, now let's see the propeller launcher in action. As you can see, the propeller flies really far, and we actually have to walk 3 houses plus a street to retrieve it, for a total range of 78 meters as measured on Google Maps. Now, this day was quite windy, so yeah, it's not super representative, but it was a lot of fun. As you can see, that's a second launch on the same day, and yeah, that neighbor is going to find a prop in their backyard this summer. Apologies for that. I made another test in a day that wasn't windy, and you can see the propeller climbing really, really high and traveling a distance of about 40 meters. Another launch right there. You'll see it looks about the same. So this device is quite consistent as long as you rotate the prop at the same maximum RPM, it's going to perform the same. And you can see now the Google Maps measurement of that launch about 42 meters without wind. So quite an impressive performance, twice as much as the Supreme launcher that I made before. Now let's look at the assembly. First, we need to assemble all of the bearings of the propeller launcher. We'll start with the top case. You could start anywhere that you'd like, but the top case is actually the trickiest. So always insert a couple BBs in the track. By the way, these are 6 millimeters airsoft BBs. I do recommend that for this top bearing track, you use the top shaft to support the bearing raise while you are inserting the BBs. When inserting the BBs, it's really important that the scallops on both of the BB components are lined up. That provides you with a hole that you can push the BB through by pressing. And yeah, each track is going to hold a couple of BBs, so you're going to need about 150 BBs approximately to do the assembly. But most kits, most bottle of airsoft BBs contain at least 1,000 and are really cheap. You can see it spins quite smoothly. An important thing when you're slicing and printing the parts with BB tracks for the bearings is to use random seams. So if the seams on your print are all aligned, it's going to create a bump in the print, and that bump is going to provide intermittent resistance in the bearing rotation, which is something you really don't want. My previous print on the Supreme launcher had those seams, and it really performed a lot less smooth on the gearbox rotation. So you really got to be careful with that. Um, as you can see, all the BB assemblies are the same. Just line the BB scallops together, the bearing scallops, and insert the BBs. And you can see a finished side of the main case. Both sides are going to be exactly the same, but symmetrical in terms of the BB assembly. Now let's assemble the pommel of the handle. This component is really instrumental in making this device easy to operate because that pommel is mounted again on the ball bearing. So it makes it really easy for the user to spin the handle very fast without having to reposition their hand that's actuating that handle. So again, you can insert a few BBs in there. Then you put the inner raise of that BB, which also acts as the mounting interface with the handle. Again, align the scallops as you can see on the top and push in the remainder of the BBs. Here is an assembled side, and it actually has 2 tracks for the BBs. That was to ensure the stability of the pommel as the user applies force on it. And yeah, it does feel quite stable when you operate the device. So this side is the same, just pushing the BBs in the opening created by the lined up scallops. There you go. It spins quite smoothly. Again, use random seams. You may need to sand, by the way. So now let's assemble the shafts and the gears for the gearbox. Um, Only one of the shafts has just one gear. It's going to be the input shaft with the biggest gear, and the three other shafts will need two gears each. And you got to pay attention to the thickness of the face width of the gears. So the thicker ones are going to be on the first shafts, and the further you go through the gearbox, the thinner the gears become. So let's assemble the first shaft. It's important to essentially put the side of the gear that has no bump, as you see here, put that towards the step on which the gear is going to rest. So the bump always has to face towards the end of the shaft, as you can see right here. So the first shaft is now assembled. Let's move on to the second one. The second one is going to be the one with the step that's on the thinnest ridge. And again, the bump has to be towards the end on which you enter the gear, as you can see here. We take the bigger spur gear, that's also the thickest one, and then you put the herringbone small spur gear next to it, again with the bus towards the end of the shaft. Those buses are there to ensure that the gears don't rub against each other or against the case while you are using the device. The third shaft is a similar process, but you start with a smaller gear. Again, the face width of that gear has to match the one on the spur gear, the larger one that you assembled on the second shaft. Sometimes the gears are a little bit tough to insert, so you may need some help from other components. Make sure you don't grab the teeth with pair of pliers because you might damage the teeth. And then you gotta put in the bigger spur gear that has the thinner face width to complete the third shaft. Let's move on to the fourth shaft. It has a wider portion on which you can put a gear, and that is destined for the bowl gear, as you can see here. Make sure it goes all the way in. Again, I have to push a little bit by resting on the table, and it goes all the way in. Then you can put on the last spur gear on the other side. Again, with the bus facing towards the end of the shaft you insert it from, as such. Now let's assemble the two halves with the gears, and you gotta decide which side you want the gears to be, which side you want the device to be operated from. It's an ambidextrous design, so you could mount it on either side that you prefer. I want to crank it with the left hand, so that's why I mount it this way. So just insert all of the shafts, starting with the first one, the input shaft, and the second shaft with the herringbone gear. Make sure it spins smoothly as such. Then you can put on the third shaft, which will have the two regular spur gears. There you go. Make sure it spins smoothly again. And the last and fourth shaft is the one with the bowl gear. Insert it with the spur gear, mating with the previous spur gear as such. And again, you can spin it and verify that it spins smoothly. Then I do recommend that you use some vegetable oil to oil the gearbox. You could use silicone oil as well. Just make sure you use a type of oil that's going to be non-toxic for humans, because I doubt you will be wearing gloves to operate this. So don't put engine oil. You really don't want to put engine oil or something like that. And then we can complete the case assembly by putting the other half. There you go. Now we will finish the assembly of the top case. So start with the top shaft. The shaft has a hole on one end as well as a step on the other. and make sure you insert the pinion gear in this direction. After pressing in the gear, it's going to rest against the step at the very end of that shaft for its location. And then you can insert that in the top case. Should go in pretty easily. And then just press in the propeller connector on the other end. So the propeller connector and the shaft have an hole. And the reason why this hole is there is because if you want to insert a piece of filament in there to ensure a secure fit, you can do that. However, on my prints, the press fit is tight enough that I don't really need to put a piece of filament there to secure it. Then we will assemble the top case with the rest of the device. Just align it and press it in. There's no wrong way to put it. And then we can secure it with the provided top clamps. Just press in one on each side. Those should fit pretty snugly as well, so you don't have to worry about those falling off. And yeah, this new design, by the way, is much simpler on the top case and main case assembly, and is much better design, much stiffer as well. Now this is the insertion of the ground effect plate. You gotta pry open the two spring tabs a little bit, make sure you don't break them. Press all the way down, and then you can rotate about 90 degrees for it to lock in place. So it's a really quick mount and dismount design. And yeah, once you're done doing all of this, just push in the handle and make sure it spins smoothly. You can see it carries its own momentum. So yeah, oil is really important. Bearing clearance is really important. Make sure you have the random seams. If the bearings are not smooth, make sure you sand them a little bit, and you should have a smooth spinning gearbox like this. Then we can clip the two halves together. So just use the clips and press them in. They should clip in easily, as you can see. And yeah, I mean, on some printers, this fit might not be as clean as the one I have on mine, because I, of course, optimized the fit for my own printer. I have a Bamboo Lab X1C, so yeah, if you have a comparable printer, like a P1S, P1P, or something that prints in a similar way, or just a well-tuned printer in general, you should be fine. Else, I do recommend that you open maybe the opening in the case a little bit with an X-Acto knife if you need to. So let's look again at the device in action. It really performs quite a bit better in the previous version, easily twice as much better. And when it's windy, it's just crazy how far these things go. Um, it's been a lot of fun to read the comments you put on the first video that I made about the prop launcher. Thank you very much for that. I actually learned by implementing the design changes, especially on the propeller blade pitch. I learned quite a bit, and it was a lot of fun. So please comment again on this video. Please share, please subscribe. That's really going to support me. And thanks for watching. Have a good one.